OpenClaw architecture because it's all about managing context, but then there's more layers to that so that you can get agentic AI to help solve problems with AI. Okay, so I don't want to claim any expertise that I don't have. I actually haven't put OpenClaw onto a computer, and the reason is the security issues and also just finding the time to do it. But I do think it's important to kind of look at the structure of how it goes so that we can plan for the future and also understand what you need to be thinking of in terms of what would be good for AI agents, because it's not going to be long before you have a safe system where you could implement something like this. All right, so first of all, we've talked about the differences between a chatbot and an agent like OpenClaw. So chatbots, the chat sessions that you get with the Frontier Labs, that they're session scoped. You have a chat window, you have the prompts that go through that. You can manage those things, and you can actually get it to call some tools. You can do web search, you can execute code. And we talked about within the Gemini framework how you could actually tap into MCP servers or things like Gmail and Spotify and different sources of information. There's limited memory. You can set things up to help with that, but there's the overall system memory, but persistence across chats is a little more of a challenge. And then there are things like scheduled tasks within the Frontier Lab models, but it's not as easy to manage. Okay, so over here with Agentic AI in an architecture like OpenClaw, you're really trying to get things to happen more autonomously, where you have some goals and the AI is trying to help you solve problems and you give it the problems and set up the goals. All right, there's a deeper tool integration. Basically, you're letting the AI do more on your computer. How much you allow is always the question, but you can basically read files, write files, send emails, connect to MCP servers, actually have the agents use your computer. All right. The other thing that's typical in the structure of an AI agent like OpenClaw is you have persistent memory. And we talked about how you can set up projects within your own file system to give AI memory across a task or across some kind of thing that you're trying to solve. All right. The thing that is also missing out of here, we talked about this, you have scheduled tasks, but in OpenClaw, I have this heartbeat going here. There's actually a timer that's intentional that fires off by default every 30 minutes so that the orchestration layer of OpenClaw is looking for things to do, things to act upon, so that you can have AI work for you as an agent. Okay, so let's talk about the architecture a little more. There's 5 layers in OpenClaw, and there's going to be other approaches to this, but this seems to be setting a standard. So first of all, you have the gateway, so you have ways of getting information into the agentic AI. And then this is an important layer that we haven't talked a lot about, orchestration, how agentic AI decides on what to do. So we'll go over that in a second. Memory and skills, we talked about that last time, how you can set that up on your computer file system. And then this heartbeat architecture where you're scheduling tasks and having things happen on a regular cadence. So the gateway, think of the gateway as ways of getting information into AI. So you could have, I set up a little app for my hydroponic system where I could talk to it with Telegram. And I like Telegram because you can put voice input directly in, you can put photographs directly in, you can just regularly text it. And I've got it set up to where I can talk to a specific agent that way. So it is useful to have more than just sitting at your computer typing into an interface. You can even have things that are a little more automated, where it's checking your email or it's checking some kind of website for data, things that happen on its own, go through the gateway, and then that gets routed to the right agent. All right. How does it get routed? Well, that's the importance of the orchestration layer. All right. So one thing that came up when I was doing some background research on this is a React loop. All right, so React is a prompting style. And basically what the orchestration layer is doing is it's giving a better prompt based on what you have for the goals of the agent. So you might actually send something on Telegram, a brief message, but then the orchestration layer needs to figure out what agent is that for? And then if I'm going to use a particular agent, what is the personality of that agent? Within OpenClaw, there's this soul.md file, which is interestingly named, where you can set that up with a certain type of personality or response or things that it's supposed to do. So the orchestration layer takes the information from your prompt or from whatever external source that it might be. It doesn't have to be a prompt, but then it reasons as to what to do. All right, so it'll figure out, do we need to make a tool call? Do we need to search the web? Do we need to call up some kind of script that processes data? It comes up with the tools that are going to be needed. Then it executes that tool call, takes an action, and looks at the output. And then said, does this accomplish the goal? If it doesn't, it iterates on that. And, because it's got some reasoning kind of things in the sense that we've talked about before. Reasoning is just pattern recognition where you're looking for steps to do. All right. Because it does that, it can iterate on this and hopefully over time get better and better and give you better results. Okay. So this is the agentic layer that's a little bit different than the regular chat interface. Chat interfaces do some of this, but it's limited. It doesn't, it wants to give you an answer within a certain time frame. And so basically it gives you that answer and stops. It doesn't do as much of this iteration step. Okay. Memory and identity. We talked about this last time, how you can set up some skills and things that you want AI agents to do. So within OpenClaw, this is kind of the file structure. This is very similar to what we talked about last time. So these are general ideas. You might not be working OpenClaw. You might be using a frontier lab to do agentic-like workflows. And if you have this set up on your computer, it gets you away from the cutting and pasting of prompts and gives you more consistent results. So it's interesting that Markdown has evolved into effectively the de facto standard for controlling these kind of things. And that's why, I've been emphasizing a simple file structure like Markdown to keep track of information. Okay, connecting agents to the real world. There's this thing called MCP servers. Think of that as like a USB interface where you have a standard for connecting to different things. Okay, so before you might have had to make an API call, and API calls are very detailed, and it's not that easy to be able to figure out how to write that into code. And so last year, Anthropic came up with this model context protocol that was adopted by the AI industry as a standard for letting AI talk to different things like your Gmail or your Google Drive or Notion, or even more interesting SaaS things like Salesforce and Slack and Teams, and ways of just getting data. The AI doesn't have to always be looking up and figuring out the details of an API call. There's some standards with MCP that makes that process go more smoothly. Now, in addition to MCP, a lot of AI is getting to where basically it just uses your computer. So computer use is also a big deal. So you might have some kind of data source that doesn't have an MCP server. And so if it's some really old piece of software, then some of the AI has actually been trained how to click and use your mouse to go to different things to access data and use that in an agentic workflow. The trust problem. The fact that AI can use your computer is problematic in terms of security. You don't want it to just do things that you don't want to give it access to financial records. You want to be careful about, if you're an instructor, you have to be careful about FERPA data. There's different aspects or places on your computer that I don't want AI to have access to. And so you have to be careful of that. Along the way, you'll hear things like Docker sandboxing, where you can have more precise control over what AI is doing. So, you don't need to know that whole sandboxing kind of thing, but the ideas of it are important because you're going to want to be able to read about and get advice about security concerns before you make the jump into agentic AI. So along the way, all through the course, we've talked about Claude, mainly because Claude is a little bit out in front of OpenAI and Gemini, and I never look at Grok, but these frontier labs, they're kind of converging on this kind of idea of an OpenClaw type of approach. In fact, I've heard some podcasts about the clawification of AI, where you're using this architecture layer to solve agentic AI problems. So in OpenClaw, they have the gateway. Within Claude, I think this is a little misfiled. There's co-work, but I would couple co-work with dispatch. So we'll talk about this in class this week. Dispatch is a way of using your phone to actually work on your regular desktop to do co-work. So it's a way, you can take this app, you can put voice into there, you can text it, you can, I think, attach images. And so that gives you a way to coordinate with Claude. All right. Within Claude, there's projects, so there's project knowledge, but more importantly, I think just like you would do with OpenClaw, with Claude Cowork, you can set up file spaces for projects where that project knowledge is contained in the file space, very much like memory files in OpenClaw. Okay, Claude also has MCP plus computer use, just like OpenClaw, and there's certain standards for setting up your file space to do that. So my point with this is that you can already, for $20 a month, you can already start participating in this agentic kind of workflow using something like Claude. And I would expect this to evolve into ChatGPT, Copilot eventually. All these things are going to have the same kind of implementation path. So within OpenClaw, there's this heartbeat idea. Within Claude, you can have scheduled tasks to take care of this idea of making things happen autonomously. So hopefully you get what I'm saying here. There's layers that you need to think about that aren't necessarily encompassed in your regular ideas of chat, okay, like a chat interface. Now, these things are becoming embedded into the desktop versions of ChatGPT and Gemini, but they're not completely there. So I think it's worthwhile thinking about the layers and thinking about what kind of applications you would have for agentic AI, starting with some really almost trivial use cases, I think, are important so that you get a feel for how it works and how much you can trust it. We'll talk about this React loop because that's a prompting method. We'll talk about that in class, where you get the prompt to tell what kind of actions you need it to take and what kind of outputs you'd like to see to drive the loop. So this is important for that orchestration layer. If you're going to run multiple agents, you have to be able to decide which agent to use and which things it needs to be able to do. MCP, we've talked a little bit about that in this video. It's been an emerging standard, but computer use is also a big deal. And so the last one on OpenClaw is that it's self-hosted, so you're kind of getting away from any dependency on one of the frontier labs, which is also a nice feature to think about. Okay, so we'll cover this more in class, and hopefully you can start doing your own experiments with agentic AI.